Okay, 4.3. We're talking about the cycle of carbon, cycling carbon. When did it occur to you that it's actually important to cycle carbon? Why do you think carbon needs to cycle in the atmosphere? What do we eat?
For energy.
For energy. For energy, mostly for us heterotrophs, we need carbon in the form of carbohydrates, lipids, proteins, nucleic acid. Because when we metabolize the food, we get energy. Is carbon important for plants?
Yes.
What do they need it for?
For photosynthesis.
For photosynthesis. Carbon is everywhere around us. Like last class, Jeff, I showed you this already. And this is now the solid form of carbon. We extracted this out from sugar. And almost all of our food contains sugar. Imagine all of our food contains those molecules of carbon. Carbon can take many forms. It can be a gas, CO2. It can be a gas, methane. It can be a solid, sugar. It can be a solid, calcium carbonate. So it can be a gas, it can be a solid. Can it also be a liquid? Yes, CO2 dissolved in water. So let's start with, I think this one. Somebody please fill this up halfway with water. This is bromothymol blue. It's an indicator. I think we did this before. Straw.
Oh yeah, the yellow
Who wants to try it today again? Can somebody explain to me the concept if you remember doing this?
I don't remember.
Somebody please.
Like they said, except we never use the blue on this. We always use like the
I never use the blue.
iodine.
Okay, who wants to volunteer to blow
you
air
blow
through
it.
this
What if we
solution?
accidentally inhale? Will we die?
No.
Isn't that the
So
contest
don't.
between
Anyone?
Pay and Brazilian girls?
I just said it might spill.
Jeff, hey, will we die if we inhale?
No, but don't. First of all, it's liquid. How would you inhale a liquid?
No, I did drink it.
You're aspirating it. But just blow, maybe in front of the camera until it turns green to yellow. Like closer.
As if you smoke, is it coloring it black and or yellow?
Smoke.
You want to try on my bath?
No. Hello. Because last year you said something about
The nicotine.
Yeah, that's juice.
It's black. It's black tar. It's purple. Alright, while we're waiting for Bea, can somebody write the equation on the board? Please. I'm tired of gyring now. Sophia, CO2 in water. Good job.
magic.
Good job. I want yellow.
Okay.
CO2 plus water. What does it become? You can guess. Come on, help friends.
CO2 plus water. It's sugar.
It's
not focused. There you go. It's focused now.
I won't die, right?
C6H12O6.
It's turning.
Joke lang.
We make sugar?
Is that?
Carbonic acid.
Joke lang.
Okay now, but then we put H first.
H2CO3.
What's sugar?
Yes, correct.
It's C6H12O6.
How do we make sugar?
Alright,
I
C6H12O6.
forgot.
we've been doing this so many times. I want you to understand the concept. Bromothymol blue is an indicator, which means it changes color depending on the pH of the solution. Bromothymol blue is green to yellow in acidic solution. Look at the equation. Bea is blowing carbon dioxide into the water. What are we forming?
Pagod na.
Acid.
Acid. This is called carbonic acid. Therefore, color to green because it's acidic. Do you want to revert it back into blue?
Drink it.
Yeah. It's not turning yellow. I don't have enough
Or
carbon.
you have to keep doing it until it's yellow.
Go, go.
All right. What you'll have to learn here is carbon can move from one place to another. Reservoir is well, you exhale into the atmosphere. That gas in the atmosphere can dissolve in. This is the beach. This is the ocean. What happens to the ocean if there's a lot of CO2 in the atmosphere? It will become acidic. Will marine organisms want an acidic environment? No. So it will actually kill marine organisms if there's too much CO2 in the atmosphere. So we're actually looking at movement of carbon right now from Bea's body to the water. Okay, I'm pretty satisfied. So you can stop whenever you want. Thank you. Good. But do you want to keep doing it until it's yellow? Like, I don't know. Good. Well, let's just try. Because I've always, like, it's there. You can go out now. Bea, you can go do it in your desk. I always try that, but the only color I can reach is green. So, I don't know. Maybe you can try. It should be yellow. What else did I want to show you? Oh, okay. Calcium carbonate. Another Sophia, equationist. Calcium carbonate. Did I tell you that toothpaste is mostly made of calcium carbonate?
No.
Okay, now you know. Chalk, blackboard, is also made of calcium carbonate. And I will forever remember that because of my physics teacher. It was Mr. Doreza. Writing, chalk. And then,
What?
and then he kept writing. Then he got another chalk.
Yeah.
And I'm like, stop it, just explain what you're doing. And he said, this is calcium carbonate. This is the same ingredient in toothpaste. And I'm like, oh, if I become a teacher, I'm gonna do that too. But we don't have chalk anymore. Have I tried? Yes. Do you want to try? Up to you.
What does it taste like?
Nothing. Chalk. Like powder.
So we're not
Powder.
gonna like die. We're
No,
not
because
poisoned.
you always eat your toothpaste,
I
right?
don't
When you were younger, you're like,
No.
all right. So chalk.
Is that good? Like
It
garlic?
doesn't smell good.
Can somebody grab me a spoon, please?
Smells like
if there's a spoon.
chemicals.
Or, Ja, you know where the spoon are.
It's on the other side.
All right,
First
calcium
drawer.
carbonate. I'm gonna mix it with an acid, which is HCl. Sophia, please. Can you please predict the product?
CACF.
Yeah, try, Sophia. Just mix and match them. And whichever looks not awkward. That's the answer.
C-A.
Is it?
Do you start with H all the time?
Yes. But let me show you what happens so you can predict the answer. Jaren said, basta meron CO2 pre.
Yeah.
But how do you know if there's CO2?
See, correct.
This is HCl.
Acid base. Yeah.
Limestone. Maybe you can look at. Guys, ready, set, go.
Is that a pill?
H2O. What is that?
Limestone.
All right, if you want, go ahead and pass it around
Joke lang.
and look at the surface of the limestone.
What?
Joke lang.
Shouldn't like those with opposite charges?
Page
No, not really.
C.
I don't get it. What are we looking at?
Look at the surface. What do you see?
Ah, it's breaking. Pass.
What's the?
The CLA
Combustion.
So what do you see at the surface?
Dissolving.
Yeah,
It's what?
H2O. Cl2.
Combusting.
Okay, so you don't see the bubbles.
the bubbles
Sedimentating.
are rising.
It's reacting.
The CO2 is releasing.
CO2 is being released. That's the bubbles. You go like, Miss, I don't really see it. Crystal, give it to me. You don't see the CO2. Let me show it to you clear.
On the left, on the left.
All right, guys. 1, 2, 1, 2,
C.
3.
CO2.
All right, now do you see the CO2?
Yes.
Oh, please tell me you see the bubbles.
And H2, CO2.
No,
Please tell me you're seeing a gas being produced, correct?
Yes.
So what gas are we producing here?
CO2.
CO2.
Correct. Please balance. Just check. That's correct.
Tama.
So we're producing water, gas, and the salt CaCl2. How do we know if there's water here? What can we do?
Milliliter.
Drink it.
I can measure by volume, but it should be the same volume.
There's water.
What did I put here? Acid or base?
Base.
Base.
Just because Justin said
An
base.
acid.
Because we already put acid.
Oh, didn't you put
What did I
Acid.
put?
Hydrochloric
So how do I
acid.
know if this has water now?
Base.
You need a base.
Acid.
If the
pH increases?
increase in pH, because this is acidic, I could have used a pH meter earlier before, then measure this now. If water is being produced at the same time CO2 is being produced, then this should be less acidic. Agree? Okay. I know this is boring, but what I wanted to learn here is carbon can move from one form to another, from one reservoir to another. You get it? Okay. I can just talk about it, but I want to show it to you so you'll remember. And remember those equations as well. All right.
No air.
We ready? Let's talk about the cycle of carbon. Thank you very much. It's been there for a week already. All right, take your seats
I'm gonna take this.
and turn it yellow.